In 9.3, we are looking at the addition rule. Now, we're going to come across this important vocabulary word called mutually exclusive. Now, when two events are mutually exclusive, that means they cannot happen at the same time. So I have this example in green. Drawing a jack and a 2 from a deck of cards is mutually exclusive because we cannot draw a jack and a 2 at the same time. Now, a non-example, drawing a jack and a red from a deck of cards, those would not be mutually exclusive because we could draw a red jack. So that's part of our addition rule. Now, why you need to know mutually exclusive is it's going to determine what you do. So when we are finding the probability of A or B, if they are mutually exclusive, you're just adding the probability of A and the probability of B. If they are not mutually exclusive, then you take the probability of A plus the probability of B, but you subtract the probability of A and B. So that would be that example of drawing that red jack. We would have to subtract that out. So here we have a box contains 2 footballs, 3 basketballs, and 4 baseballs. A ball is selected at random. Are the events of selecting a football and baseball mutually exclusive? So what we want to think about is if I grab one ball out, can it be a football and a baseball? It cannot. I cannot grab both of them at the same time. So yes, it is mutually exclusive because you can't pick a football and baseball at the same time. So then we're asked to find the probability that the selected ball is a football or baseball. So when they're mutually exclusive, that's P of A plus P of B. So the probability of picking a football is 2 out of, there are 9 balls in total. So 2 out of 7. Plus the probability of picking a baseball, there's 4 baseballs, so 4 out of 9. So 2 plus 4 is 6 out of 9, because those denominators stayed the same, and 6 out of 9 reduces to 2/3. So are the events of selecting an ace or a 10 mutually exclusive? So if I think about my deck of cards, so here I have a deck of cards. If I look, my aces are in this first column, and then my 10s are over here. I can't pick an ace and a 10 at the same time. So those are mutually exclusive. Yes. We'd have a similar explanation because we can't pick an ace and a 10 at the same time. So the probability of selecting an ace, if I go back, there's 1, 2, 3, 4 out of 52 aces. plus the probability of a 10 is 4 out of 52, which is 8 out of 52, and that reduces to 2 out of 13. Right. Are the events of selecting a queen or a diamond mutually exclusive? So if I look at my deck of cards, I look at my queens, and here we can select this queen that is a diamond. So because of that overlap, they are not mutually exclusive. So not mutually exclusive because we can pick a queen and diamond at the same time. So the probability of selecting a queen or diamond, now this is when we have to use P of A plus P of B minus P of A and B. So A will be our queen, diamond will be our B. So the probability of drawing a queen is a 4 out of 52, plus the probability of drawing a diamond, there's 13 diamonds out of 52 cards, minus, what is that probability that we pick the card that is the queen and the diamond? And there's one card out of 52. If I look back at that deck, this is that one card that is my queen and my diamond. So 4 plus 13 minus 1 is 16 out of 52, which equals 4 out of 13. Are the events of selecting a 4 or a red card mutually exclusive? If I look at my deck of cards, I'm looking at the 4s, and here I have 2 4s that are red. So I can pick a red and a 4 at the same time. So these are not mutually exclusive. Because there are 2 red 4s. So because it's not mutually exclusive, we're using the probability of A plus the probability of B minus the probability of A and B. So A will be our 4, B will be our red. So the probability of drawing a 4 is 4 out of 52. Plus the probability of a red, there's 26 red cards in a deck out of 52, minus, if I look back, I had 2 red 4s. So that's the probability of A and B, 2 out of 52. So this is going to give us 28 out of 52. If I reduce this, I get 7 out of 13. Okay. Example, what is the probability of selecting at random a queen or a king? If I look at my deck of cards, queen and king, there's no overlap between those. I can pick just a queen or just a king, but not both. So these are, I'm going to put ME, mutually exclusive. So that is P of A plus P of B, which is 4 out of 52 plus 4 out of 52, which equals 8 out of 52, which reduces to 2 out of 13. So what is the probability of P of A or B given? So when you're given problems like this, for problems like this, because we are given this P of A and B, and this is a number other than 0, we know that we will use P of A plus P of B minus P of A and B. So 0.8 plus 0.3 minus 0.1, that is going to equal 1. So the probability, since that is 1, is 100%. Try another one. P of A plus P of B minus P of A and B. So 0.4 plus 0.3 minus 0.2. This would be 0.3 plus 0.4 plus 0.3 is 0.7 minus 0.2, 0.5. And that is our addition rule.